Exactly. All right. Now, you've got some basic derivative rules. So you know what the derivative of a constant. What's the derivative of a constant? Zero. If you have the derivative of a single variable like x or z or whatever, that's your independent variable, that derivative is just 1. That's just a special case of your power rule. Your power rule says that your power comes down and becomes your coefficient. All right. Then your variable stays the same. Tracking off. All right, the variable stays the same, and then your power decreases by 1, so that's your power rule. You've got another one that says if you've got a sum, instead of doing the sum first and then taking the derivative, you can take the derivative and then do the sum. So what it basically says is the derivative of a sum is the same thing as the sum of the derivatives. It also works on a difference, so you can split them up. You've got one that says if you've got a constant, you can take that constant and pull it out front. So it's the constant times the derivative. Now, some of those you worked before, you can rework using product rule or quotient rule. But I'm not going to tell you on a test which way to work it. You get to decide which way to work it. All right? But I need you to understand, if you're doing the derivative of a product, so I've got like an f of x times a g of x. It is not the derivative of the first times the derivative of the second. That does not work. So I wish it did, but it doesn't. And like I said, they do a really nice proof in your book. Basically what they do is they take the definition and they add a 0 in a certain form. And then split it up and it works out really nicely. So I wish I had time, but I don't. So what we're going to do is this. It's the first times the derivative of the second plus it's the second one times the derivative of the first. Julia?
I know that you're a proponent of the community property of addition, but in this case, will you be salty if I switch them?
No.
Okay.
Okay.
Now.
Okay. I like that phrase.
Are you okay? Yeah, I just yawned.
Okay. I like that phrase. Okay, yeah. I'm salty upon occasion, so yeah. Give you my word.
Somebody forgets.
Now, I'm going to show you some that you can work either way, but you're going to have to do the product rule when you've got like a transcendental times an algebraic function. So you can't avoid the product rule all the time. Sometimes you can, sometimes you can't. Now, here's what I mean. Suppose your function looks like this. Now, I'm going to work it an old way, then I'm going to work it this new way. Okay? And I wouldn't care which way you worked it. Then I'll show you one where you have to work it this way. All right? So do we understand? You could have had this for homework before, but what would you have had to do first? You'd have multiplied it out. So you'd have had 3x squared plus 15x, correct? And then you just said, okay, what's my derivative? What's it going to be? 6x plus 15. Done. And that's the way I would work it all the time. But here's what the product rule says I can do if I want to. Let's make sure we're clear. I'm just going to copy down the first one, 3x. Now, what am I going to multiply it by? The derivative of what? All right, so what's the derivative of x plus 5? 1. Does everybody see why it's 1? Because the derivative of that constant is just 0. And it says plus. Then I copy down the second one just like it is. And then I do the derivative of the first one. So what's the derivative of 3x? 3. So I do the first times the derivative of the second plus the second times the derivative of the first, and then I just clean it up. So I've got 3x plus what? 3x plus 15. So I end up with 6x plus what? 15. Which is exactly the same thing I got over here. Show you?
If we didn't include that one in our work, would that be bad?
It's not wrong, but especially on this next test, I'd like to see it.
Okay.
Okay. Does everybody understand what she's asking? And she was just doing that in her head. All right, now, here's what I talked about before. To me, it is better to play algebra first than to play algebra at the end. But it's a completely personal preference thing. I wouldn't care if you worked it this way or that way, just give me the right derivative. But if I gave you this one, you wouldn't have a choice. All right, what if I tell you, here's your function?
Yummy.
Yummy, yeah. Now, first of all, you've got to recognize it's a product because they're not in parentheses. But you're college, you know that means 6x times cosine x, but you've got to recognize that. So we understand that 6x is one of our functions, and the cosine x, with the marker that actually writes maybe, is going to be the other one. So there, I can't play algebra before. So I'm going to have to go do the derivative. So I have the first, and then I need the derivative of the second. So what's the derivative of cosine x?
Negative sine x.
Negative sine x. And then it says plus, and I copy down the second, cosine x, and then I need the derivative of the first. So what's the derivative of 6x?
6.
So my derivative ends up being a negative 6x sine of x plus 6 what?
Cosine of
Cosine of x. There's my derivative. Now you might turn to the back of the book and they might have factored out a 6. Well, cool. I got stuff to do. Okay? There's no way of knowing what form. There's some are obviously not simplified, but some is really a matter of personal preference. Okay? So that's what you're going to do with product rule. Everybody okay? Okay. Now let's talk about quotient rule for a minute. All right? And then I'm going to let you work a couple to practice, and then we're going to move along. Now, the more you do them, the quicker you get better at them. All right? So if you've got a function that's like an f of x over a g of x, okay, and you want to take the derivative. Again, it is not the derivative of the numerator divided by the derivative of the denominator. I wish it was, but it's not. Okay? So what it is you copy the denominator down. So it's bottom times the derivative of the numerator minus the numerator times the derivative of the denominator. And all that is over that denominator squared. So you got to learn that. You got to learn the formula, learn the rule. Okay? So that's the reason I said it's not my personal favorite. It's not hard, it's just long. And I'm a careless person, so the longer it is, the more likely I am to make a careless mistake. Okay? But again, you've got to learn the rule because sometimes I can avoid it and sometimes I cannot avoid it. So let's do one where I could avoid it if I wanted to. If I had 3x squared minus x plus 4 over x. You've had problems like that before, like the one a minute ago that had the fractions on. I can play algebra first and simplify that. What's 3x squared divided by x going to get me? X divided by x is going to give me what? 1. And then I've got my 4 over my x. So I've got 3x minus 1 plus 4x to the what? Negative 1. Everybody okay? Now, haven't done any calculus yet. Now I'm ready for my calculus derivative. What's the derivative of 3x? 3. Minus, what's the derivative of that constant? 0. And then when that negative 1 comes down, it's going to make it what kind of 4? Negative. So I've got a negative 4x to the what? 0. To the negative 2. Everybody okay? So I've got 3 minus 4 over what? Is everybody okay? Now, you might box it and be finished. Now look what happens when I use this rule over here. The form's going to look a little different at the end. Do I start on the bottom or the top? Where do I start? I start on the bottom. So that's a little bit counterintuitive, so you gotta be careful. So I'm gonna copy down that denominator. So I'm gonna copy down this x. I'm doing the same problem. Now, what do I take the derivative? I take the derivative of the numerator. All right, so you tell me, what's the derivative of 3x squared? It's gonna be 6x. Everybody see why it's 6x? And then minus, what's the derivative of x? 1. Now plus, what's the derivative of that constant gonna be? 0. So does everybody see that the derivative of that numerator is 6x minus 1? Okay, plus or minus, it says what? Minus. Then it says copy down the top. So I'm just going to copy down 3x squared minus x plus 4. And then I do the derivative of that denominator. So what's the derivative of this denominator over here? Just 1, isn't it? And all of that is over my denominator, what? Squared. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom what? Squared. Now the rest is algebra. That's the only calculus to it is that first step. All right. So if I expand it out, I'm going to have what? 6x what? Squared minus x, and then what? Minus 3x squared plus x, and what? Minus 4. All over x squared. All right. What cleans up in the top? Well, what's 6x squared minus 3x squared going to get? 3x squared. What happens to my x's? Don't they divide out? They add to 0. And then I'm left with what? Minus 4 all over what? Now, I've got this for my answer. I turn to the back and they've got that. Are they the same?
Yes.
Yes, they just got a common denominator. What's my common denominator going to be over here? X squared. Right? So if I wanted to get a common denominator, you multiply 1 by x squared. So you got to multiply 3 by what? X squared. And then if this is x squared, it stays x squared. If that's 4, that's going to stay 4. They are algebraically equivalent. Okay? So I don't care if you have one you can work multiple ways. You get to decide which multiple way you want to do it. But again, sometimes you don't have a choice. So if I gave you this one, all right. Now we no longer have a choice. I can't play algebra to start with. So if I want the derivative, which one gets copied first, the top or the bottom? The bottom is just sign x. All right, what's the derivative of your numerator? What's the derivative of e to the x? It's our favorite, e to the x. So bottom times the derivative of the top, plus or minus? Minus. Then I copy down the top, and I need the derivative of that denominator. So what's the derivative of sine x? Cosine x. And then all that's over my denominator, what? Squared. So whichever way you want to write it, I mean, you have e to the x times sine x minus e to the x times cosine x. Now you do know, usually they're going to write it like this. Is everybody clear that that means the same thing as that? Now again, couldn't they factor an e to the x out of the numerator if they wanted to? Yeah, I don't know that it does any good, but you could. If I turn to the back and they factored it out, you're like, okay. So you've got to be able to do the product rule and the quotient rule. All right. So let you try a couple of them real quick, and then I want to talk about a little bit of trick. Matter of fact, let's just do that now, shall we?
No.
Oh, yeah.
Practice.
All right. You know I love trees. All right. Here's your function. Find me the derivative. Right, you help me. Where do I start? Top or bottom? Bottom. So I just copy down 1 minus sine x. Then I do the derivative of the top. Now, what's the derivative of cosine x?
Negative sine x.
Negative sine x. All right, plus or minus on quotient rule?
Minus.
Minus. All right, so I do bottom times the derivative of the top minus the what? The top. And then I do the derivative of the bottom. All right, so what's the derivative of the 1 going to be?
0.
0 minus, what's the derivative of sine x?
Cosine x.
And all that is over 1 minus sine x what?
Squared.
Squared. Okay. So do we understand at the top, I've got a negative sine x. Is that going to be plus or minus? Plus what? Sine squared x, or sine x in parenthesis what? Squared. That's the same thing. All right. And I'm going to have minus. Now, what's cosine x times 0 going to give me?
0.
0. I'm going to put minus 0 just to make sure we're clear. And then I've got this minus cosine x times a minus cosine x. What's that going to give me?
Plus cosine squared x.
All over 1 minus sine x in parentheses squared. So is that what you got? Now I'm just going to erase the minus 0 because I don't need it. Is everybody with me? So what are you going to do when you turn to the back and all of a sudden you see this? What happened? What is sine squared plus cosine squared? 1. So way back at the beginning of the semester, I told you there were 3 trig identities that I expected you to memorize. The Pythagorean identities are in the front flap of your book, and this is one of them. So I would expect you to know that's a negative sine x plus what? 1. Over 1 minus sine x what? Squared. Well, a negative sine x plus 1, what's another way of writing that? 1 minus what? Sine x. And on the bottom, I've got 1 minus sine x what? Squared. Everybody with me? So do you understand that you've got a 1 minus sine x on the top, and on the bottom, how many of these 1 minus sine x's do you have? 2. So if you need to write it out to see it. So what's going to happen to one on the top and one of them on the bottom? They're going to divide out as long as sine of x is not 1. Is everybody with me? And how do I know sine x couldn't be 1? Because if sine x was 1, there'd be no problem to begin with. Everybody with me? That wouldn't be in my calculation. So I turn to the back, and I'm going to have 1 over 1 minus sine x. So you're going to be careful with these trig ones. Because sometimes you'll do it right, but you'll check the answer from the back, and it won't look anything like that. And you're like, where did that come from? That's probably where it came from. So those Pythagorean identities, we do need to know. Okay? So is that, does everybody understand? Now, these are not hard, but they are lengthy. Is everybody with me? That's why a lot of times you'll see me avoid the quotient rule unless I just have to use it. Some people really like it and they use it all the time. It's just a personal preference thing. Okay? But you do have to be able to use it because sometimes you've got to be able to use it even when it's not trig. Now, I'm not going to take time to work this one, but does this make sense? If your function was just something like x plus 1 over x minus 3, do you see I'm going to have to use the quotient rule on that? I can't really play any algebra and make it any better. So somehow you've got to remember, I mean, I used to have a student that would just, I'm like, what are you doing? And they were singing, and it sounded like they were singing something from like the Snow White and the Seven Dwarfs. It's like Lodi high minus Heidi low over low low. Whatever works. Okay? So why did they do low D high? What was their way of saying? Low was what? Bottom. And D high meant derivative of the top minus high, D, low. So the top times the derivative of the bottom over low, which is their way of saying the bottom times itself. Is everybody with me? So I don't make up a tune, I don't care.
Pretty smart.
All right, so whatever works for you, but you've got to be able to tell me the formula for the product rule and use it, and the formula for the quotient rule and use it. Now, so let me ask you this. Then we should be able to figure out the derivative of this thing. I love a thing. And it's trig!
I know.
Now, the two trig ones you know so far, what's the derivative of sine x?
Cosine.
Cosine x. What's the derivative of cosine x? Well, now we got to learn tangent, cotangent, secant, and cosecant. Oh, yeah.
I don't think we need to.
I think you do.
It's just a
I
beginner
want you to
level
have
class.
the fullness of life.
It's a beginner level class. We don't need it.
Now, what I'm going to do is use the quotient rule to figure it out. So this one we'll do a real quick proof. So how do you write tangent as a quotient? Sine x over what? Cosine x. All right, so if I want to do the derivative, low d high, so where do I start? Cosine x over 4. Okay. Now, what's the derivative of that numerator? What's the derivative of sine x? Cosine x, isn't it? Plus or minus? Minus. Then I do the numerator, high d low, so the top. What's the derivative of that bottom? What's the derivative of cosine x? All over the bottom, what? Square. Okay. So on the top, do you understand I've got cosine what? Squared x, what? Plus what? Sine squared x. All right. Now, just to emphasize something, I'm going to write this as cosine x times cosine x, just so you can see something in a minute quickly. Now, we've already said Pythagorean identity. What's sine squared of an angle plus cosine squared of an angle? 1. Like Julie pointed out earlier, community property of addition says that if it's cosine first, it still should be what?
The same.
The same. So I've got 1 over cosine x times another cosine x. Is that correct? So could I write that as 1 over cosine x times another 1 over cosine x?
Yes.
What's 1 over cosine x the same thing as? Secant. So that's a secant x times another what? Secant x. So what did we figure out the derivative of tan x is?
Secant squared x.
Secant squared x.
Wait, that's a property. The 1 plus.
Do what, Lauren?
That's a property. The 1 plus tangent squared x equals secant squared x.
There is a property with that, nothing to do with that, but yeah, it is a property. That's right. That's one of your other Pythagorean identities. All right. Now, I'm not going to take time to do the other proofs, but you may have to, that would make a nice little question, wouldn't it? All right, now.
No.
Oh, man. All right, so we already know these, correct? Can you tell me the derivative of sine was? Cosine x. Derivative of cosine x is negative sine x. So that's the first and second one. Now you got a third one. If you do the derivative of cotangent x, you're going to get negative cosecant squared x. Now again, that's a simple proof. Only instead of having sine over cosine, what would you have? Cosine over sine. And use the quotient rule and you can prove it. All right. The derivative of secant x is secant x times tangent x. Now, how would you write secant x as a quotient?
1 over cosine.
1 over what? Cosine. And then again, you could use your quotient rule and do the proof. The proof is pretty straightforward and pretty simple. Okay. And then the derivative of cosecant x is negative cosecant x cotangent x. So before I bopped in here next time, I know those 6. Hint, hint, hint.
Great. Guys, don't win them. There's no need to.
Just wing it.
Okay. Because there are gonna be something when you take that second test, it'll be a week and a half or 2 weeks or so, that you're just stuck. If you don't know what the derivative of tan x is, you can go derive it again and figure it out. But it's quicker to just know it. Is everybody with me? Okay. We get so far. All right, now, here's what I want you to do for a few minutes. All right.